Hey kids, welcome to Unit 2, Lesson 5, Constructors and Inheritance, Exercise number 7. We have a choose your own adventure. I'm just going to note for this, the next couple of lessons are all going to build off of which class you choose here. That means if you go with Cookie, you're going to have to do the Cookie class for the next couple of lessons. Just keep that in mind when you're selecting. I'm going to do the delicious pie class. Let's go ahead and see what we have to code up. Now, the Joyful Pastries food truck owner can create dessert objects with specific flavors and prices. They would like to create pie objects with specific values as well. We're going to import the dessert and pie classes from our backpack. If we don't have it, that's fine. We can go here and paste it in. I know I have my dessert class ready to go. We can import that. As you can see, I have my two public instance variables, a no argument constructor, and a two argument constructor. Both of these are using the this keyword to signify use the local variables from this constructor. My pie class I don't have, but I can build one. Let's do a new file, pie, and then we're going to create. This is going to be a public class pie. Need some curly cues. My end of class. This one has an instance variable of a diameter. So we're going to go private int diameter. We should label our private instance variables because I believe we're going to add some more in the upcoming lessons. I need a no argument constructor or default constructor. And this is going to be a public pie, no arguments, and some curly cues. And let's take a second and talk what we're going to put inside this. This lesson is about inheritance. The one thing I forgot up here was pie extends dessert. That means dessert is the superclass and the subclass is pie. Remember, through inheritance, we get a copy of the methods. And technically, we also get a copy of the instance variables. But I just want you to note they're private. You really don't have access. You just have access to a copy of the variables with no access. What's important to this lesson is in inheritance is we do not get constructors inherited from each class. My dessert class does not give my pie class the dessert constructor. And if you think about that for a second, that makes sense. One's a dessert object, one's a pie object. But just like this keyword where we use to refer to the local variable to clean up and make our code more efficient, and super lets us access the constructor signatures and their parameters so we don't have to build a new object. If you look at this graphic here I made, I have a person class, a student, and a teacher class. Both teachers and students is a person, but not all students are teachers and not all teachers are students. They have a relationship though because they share the same superclass. And if you think, we share subclasses because they have a lot of things in common. They're blueprints, and we build upon those blueprints. That means I can take these constructors from the superclass and I can call them. So think of the super keyword is able to access the constructors from the parent class. We cannot access constructors between the subclasses. Has a means they have a relationship. And just because they have a relationship, they're not going to have the same type of constructors. So we can't share those. We can only share from the superclass. Let's take a look at what this means in some code. In my person class, you can see I have two instance variables, name and age. I have a default constructor, and I have a parameterized constructor, person, which is name and age. There's some other neat code you can't see. But let's think of the parameterized constructor here of just this little block, person, string name, and age, because that's what makes up a two-person parameter object. If you look at my student class here, My instance variables is just going to be grade. Default constructor doesn't inherit my instance variable values. In subclasses, we only put the default we want for that subclass. In our parameterized constructor, we also want a name and age. If you think back to our this keyword, we use this to refer to the local variable. We can get around this by creating a new local variable name. We don't want our code to be redundant. We want to use the dry method. Don't repeat yourself. This super keyword we're going to use to refer to the constructor in the super class we want to call. If you think back, it was person string name and age. Super is just going to be a substitute for the person class. We don't know what the name of the class. We just know it's from the super class. Then we just match the parameter for the constructor we would like to call. In this case, it has the 2. So person string name and age is the same as super name and age. Think of super as just a variable name referring to that constructor of the superclass. That just means we just match the constructor parameters for the constructor we want to call from the superclass. If you'll notice, there is no constructors for pi. So for pi, we are just going to go this is going to refer to this diameter. And we'll say 12 inches is going to be the local variable for my default. On to my parameterized. This is going to be a public pi again. We'll put our parentheses and our curly cues. And in this one, we want to be able to, because we've already built a dessert object that has a flavor and a string. We don't want to have to rewrite this whole constructor. That would be an inefficient use of code. That means if we want to reuse this constructor, we're going to substitute super in for the flavor and the price. What does that look like? First, we are going to pass our parameters along. It is a string flavor, a double price. We're also going to add our int diameter for the parameter we made for this class. I want to reuse that string flavor, so super, just to mean the super class. We're going to do our parentheses and a semicolon. And what are the parameters we're going to reuse? The flavor and the price. And this is just, again, a way to make our code more efficient, easier to read. We're not done. We still have to go over here and refer to this diameter is going to equal the diameter. And that's how we use the super keyword to make our code a little more efficient. Another note, super has to be the first line. If you think about what a constructor is doing, it's creating an object. We can't start adding these parameters in until we build the first part of it, which is the flavor and the price. Just keep that in mind. We're not done yet. We have to go over to the food truck runner. Over here, we have to instantiate some objects. We're going to call our default. It is a pi. We'll call it roads1. It equals a new pi, and it's just a default, no argument. We should probably comment this out. This is default object. And now we have to create our 2-parameter object. That is also going to be a pi. We'll call it roads2 equals a new pi. We have to give it 3 parameters this time. Our flavor, we will make it apple. Price, $19.99. And then the diameter, I like my pies big, so we'll go 24 inches. Now we have to see if these actual constructors will print. So we're going to go down here and copy this bit of code. Copy this in. Make sure we're calling a object from that class, roads1. When I hit run, I should get my pi default object and my 3-parameter constructor pi object to print off. Well, let's see if we're correct, kids. And we did. You can see we got our string double and int, and we borrowed the string and double from the parent class, so we didn't have to create a new one. That's all super was doing. The key takeaway from this lesson is understanding a little more about how inheritance and hierarchy works in Java. Looking at this graphic again, I have a person class. All students are people, all teachers are people, despite what you think. But not all teachers are students, and not all students are teachers. This is our is a relationship, subclass, superclass, and has a relationship between our subclasses. When we use extends to use inheritance, we do inherit the default instance variables, but just a copy of the list as we saw, and we get a copy of all the methods. What we don't get are copies of the constructors. And if you think about it, a person constructor really wouldn't work in a teacher or student class because it's a blueprint. We've learned, though, that Java is obsessed with efficiency. Remember our dry principle, do not repeat yourself. And this is one of those principles. We can use the super keyword to call one of the constructors so we don't have to rewrite it. Just think of super as a substitute for whatever the constructor's parent class name would have been. The anatomy is we have the super keyword, and inside the parentheses, we want to match the parameters of whatever constructor we want to recreate. In this graphic here, it's name and age, but in our lesson, it was flavor and price. Again, just think of super as a placeholder name for whatever constructor we want to call from the super class. Finally, we learned that the super keyword has to be on the first line because what we're doing is creating this object, constructing it. And we can't pass parameters to parts of the object that don't exist yet. Hopefully, this video helped you understand the super keyword, constructors, and inheritance a little better. As always, kids, if you have any questions, come see me. Otherwise, I'll see you on the next lesson. See you later, kids. Bye. Bye.